Sweet. Alright, so yesterday we talked about adding and subtracting, we talked about scalar multiplication. That stuff was really easy, right? Scalar multiplication, we just distributed that number through. Today we're going to actually talk about multiplying matrices. So before we can even multiply a matrix, we need to look at their dimensions, because we need the columns of A to be the exact same as the rows of B. Now, there's going to be an actually really easy way to check this, and I'll show you in a second. But we need the number of columns in A to be the same as in B. If they're not the same, it is undefined. We cannot multiply them. And we'll see why, because we'll have an example where they aren't the same, and I'll show you why we can't actually multiply them. Alright, so the number of columns in A must be the same as rows of B. As an example, if we have a 2 by 3 matrix, we're multiplying by a 3 by 4 matrix. If you write out the dimensions, these middle numbers should be the exact same. Right? Because that's the columns of A and the rows of B. So if you write them out, they should be the exact same. If they're not, it's undefined and you can't multiply them. Now the other really cool thing, if you look at it, is this tells us if we can multiply them, and then our answer matrix. Remember we added 2 matrices yesterday, we got another matrix? Same thing, when we multiply 2 matrices, we're going to get an answer matrix. That answer matrix will be a 2 by 4 matrix. Right? So if you look at the inside parts, it tells us if we can multiply, and the outside parts tell us how big our answer matrix will be, how big the dimensions will be. So our dimensions for our answer matrix then would be a 2 by 4. Alright? It's going to be a little bit easier to see when we actually do a couple. Alright? Just another example here. If we're looking at matrices that we want to multiply, I have a 2 by 2 matrix times a 2 by 3 matrix. They're the same in the middle. Right? So that means I could multiply them. And I would end up with a 2 by 3 matrix as my answer. 3 by 2 times a 2 by 1, same in the middle. So I can multiply them, I'd end up with a 3 by 1 answer. Alright, does that kind of make sense? A little bit? Alright. Now, actually multiplying the 2 matrices is totally different than adding them. We are not just going to multiply 1 times 7, 2 times 8, because obviously they don't match up. Right, look at those 2 matrices. I have a 2 by 3 and a 3 by 2. My middle numbers match, but I can't just multiply across. It's not how we do it. What we do is we call the dot product. What's going to happen is in your first matrix, you're going to take a whole row. And we are always taking rows from our first matrix. Okay? So we're going to take a row, and we're going to multiply using the dot product by a column from our second matrix. Alright, so rows from the first matrix, columns from the second matrix. So, how are we going to do that? Doing the dot product, what's going to happen is you're going to take the first number in the row times the first number in the column. 1 times 7. And then I'm going to add the second number in the row times the second number in the column. 2 times 9. And then I'm going to add the third number in the row times the third number in the column. 3 times 11. That's what we call a dot product. So we're taking the first numbers, multiplying them together, adding the second numbers, multiplying them together, adding the third numbers, multiplying them together. So I get 7 plus 18 plus 33 equals 58. Now, you'll notice from our dimensions, we knew this is going to be a 2 by 2 matrix. And they already put 58 in there for me. How do they know where it goes? How do they know it goes in the top left spot? Because they do have certain spots to go into. Can I just put it anywhere? No. How do we know it's the top left? Well, we could have found any of them first. We could have found the bottom right one first if we wanted. We don't normally. You normally find the top left, top right, bottom.
Because you're multiplying the top and the left.
Because what? Not the smallest number, no.
You're multiplying the top one and the right and the second left one.
Perfect. We're multiplying the top row and the left column. So I know it's going in the top left spot. Alright, or the top row in the first column, so the top first. Alright, so that's going to tell us what we're using, the row and the column, is going to tell us the position in the answer matrix as well. So now what I'm going to do is I'm going to take the top row, and I'm going to multiply it by the second column. So I want to find this top right spot. So I'm going to take 1 times 8. And I'm going to add 2 times 10. And I'm going to add 3 times 12. So I get 8 plus 20 plus 36 should give me 64. And I use the top row right column, so it goes in the top right. Crazy, right?
Yeah.
So then I'm going to use the bottom row, the left column. 4 times 7 plus 5 times 9 plus 6 times 11. So 28 plus 45 plus 66 should give me 139. So because I use the bottom row in the left column, I'm going to put it in the bottom left spot. So 139. Does that make sense? Okay. Then the bottom row, right column. 4 times 8 plus 5 times 10 plus 6 times 12. So we get 32 plus 50 plus 72. Should get 154. And that's the bottom right spot. Okay? And that's our answer. Right there, that matrix. Does that make sense?
Yes, perfect.
Do we have any questions on that?
No.
No?
Nope.
Alright, let's try one more together. First and foremost, like I said before, check and make sure we can multiply them. This is a 2 by 3. This is a 3 by 2. Are my middle numbers the same?
Yes.
Yes. What type of answer matrix should I get based on dimensions?
2 by 2.
2 by 2, right? The outside numbers. So now this is a 2 by 2. Okay. Top row times left column. 3 times 9 plus 4 times 4 plus 5 times negative 3. Right? First numbers multiplied together. Second numbers multiplied together. Third numbers multiplied together. Add them all up. 27 plus 16 plus negative 15 should give me 28. Top left. Guys, you think you have to write out all those steps?
No.
No, right? You're young adults, I trust you. Now, if you write the steps out, it's way easier to see if you make a mistake. But I'm not going to sit there and tell you have to write out every single one of these steps. Alright, top right. 3 times 1 plus 4 times negative 2 plus 5 times 7. So 3 plus negative 8 plus 35 should give me 30. That was the top row, right column. Alright, bottom left. Negative 1 times 9 plus 2 times 4 plus 6 times negative 3. So negative 9 plus 8 plus negative 18 should give me negative 19. That was bottom left. Then lastly, bottom row, right column. Negative 1 times 1 plus 2 times negative 2 plus 6 times 7. We should get negative 1 plus negative 4 plus 42, which should give us 37. So that's our last spot, bottom right. Okay, does that make sense?
Yeah.
Do we have any questions on that? Awesome. There are 4 you-try problems if you turn your page. Now, here's the deal. I will give you a hint. There is one of them that you cannot do. 1 out of the 4 you will not be able to do. Alright? So, go ahead, try them, test your dimensions first and foremost, make sure you can multiply them, and it tells you how big your answer matrix should be. Go ahead. If you're getting stuck, if you're struggling, raise your hand, get some help, talk to someone next to you. Right? But don't just sit there and stare at your paper mindlessly. Right? That's not going to help you at all. Ask a question if you're stuck. sure? Did she test your dimensions?
She did not.
Oh, you were the one that said the first one.
I was just doing my looks, but then I tested dimensions and I changed my answer.
Yeah.
Yeah.
Remember, we're always taking a row from the first matrix, multiplying it by a column from the second matrix. If we're stuck, ask a question. Raise your hand. As smart as I am, I can't read your mind.
If you can't do it, what would you have to like explain to me?
What?
If you can't do it, should you explain why you can't do it?
I would just say it's undefined. If you can't do it, I would just put undefined. If I can't multiply something, it's undefined. If I divide by 0, undefined. So I'll give you maybe a couple minutes to work on the top two, and then we'll go through the top two, and then give you a couple more minutes to work on the bottom two, and we'll go through the bottom two. All right? All right, let's try and go through those top two. Then I'll give you some chance to go through the, work on the bottom two a little more. All right, top two. You can do them both. All right, first one, a 1 by 2 matrix times a 2 by 3 matrix. 2's in the middle, so I know I can do that. Ends up being a 1 by 3 answer matrix. Take a row times a column. A row times a column. Row times a column. Take all three your answers, you got 38, 3, negative 21. The next one, a 2 by 2 times a 2 by 2. 2's in the middle. No, I'm going to have a 2 by 2 answer matrix. I should get 48, negative 31, 108, negative 67. Are there any of them you want me to go through? Any of these numbers that you didn't get? You want me to show you how we got them? Anything like that? Do we need maybe 1 or 2 more minutes to check out the bottom two?
Yes.
Alright, I'll give you a couple more minutes to do that, but I do want to get going quickly so that we can get you some work time before the weekend. And I'm a nice person, I get it.
Pretty sweet guy.
If you're struggling with either of the bottom two, or you still have a question on the top two, feel free to raise your hand. I'm more than happy to help you. Talk to a friend nearby, ask them for help, anything of the sort. But don't just sit there. Let's go with about another 30 seconds on those bottom two. Alright, I know you may not be finished with the bottom two, but I really want to get to the last problem because it is a really important problem, and I want to get you some work time. Alright, so we're going to go through the bottom two. Obviously one of them you couldn't do because I told you one of the four you won't be able to do. That was the second one. We'll talk about that in a second. The first one, however, on the bottom, we have a 3x2 matrix times another 3x2 matrix. My 2's in the middle are the same, so I know I can multiply them. My answer should be a 3x2 matrix. Alright, I'm taking rows from the first matrix times columns in the second matrix. Top left should be negative 114. Middle left should be negative 49. Bottom left should be negative 68. Top right, negative 50. Middle, negative 20. Bottom, negative 34. Alright? The second one, so 3x2 times a 3x2. My numbers in the middle do not match up. I know I can't multiply it. I call it undefined because of that. But why can't I multiply them?
Because they're different.
Well, they're different, I know, but why does that matter? What does that matter? Yeah.
The row and the column won't, or wait.
Yeah.
Yeah, they don't match up.
They don't match up, right? If I take a row and a column, I have 2 numbers in my row and 3 in my column. They won't match up. That's why we can't do it. Alright, does that make sense?
Good.
Alright, any questions on that? Alright, the next problem, the last problem for today, I would put a star by. It may show up on something at the end of the unit that's really important. I forget what the thing's called, I don't know. But who knows? It might be really important. So I may put a star by it, make sure I know how to do it. Let's try this one, solving for x and y. How can I solve for x? Let's just worry about x, not even y.
Okay.
How do you think we could solve for x? Yeah.
Do the line up a row in the column and like solve for them.
So you'd say take a row,
Or
certain row,
the 2 and x.
2 and x, right? We know we have to take a row from our first matrix. So let's take the row with x in it. Alright.
And then negative 6 and 2.
Negative 6 and 2. Could I use 8 and 14?
Yeah.
Yeah. Right? I could use either column here. And then how do I know what it's going to equal?
It's going to equal 6.
6, right? Top row, left column is going to equal 6. So if I do the dot product here, I do 2 times negative 6 plus x times 2, it should come out to 6. And we can all solve an expression, or excuse me, an equation like that, right? We get negative 12 plus 2x equals 6. So I'm going to add 12. 2x equals 18. And divide by 2.
X equals 9.
x equals 9. So we're still multiplying matrices like we have them before, but we're just going to make sure we take the row that has x in it, multiply it by a column that has no other variables, and figure out what its answer is in the answer matrix and solve it. Same thing for y, except I'm going to take the row that has y in it, multiply it by a column that does not have any variables in it, and the bottom left, so negative 100 is what it should equal. Well, y times negative 6 plus negative 5 times 2 is going to equal negative 100. Does that make sense? Why we took those different pieces? Do you have any questions on that? Alright, then we're just going to solve it out. Negative 6y plus negative 10 or minus 10 equals negative 100 plus 10. Negative 6y equals negative 90. And divide by negative 6.
Y equals 15.
Y equals 15. So like I said, I might make sure I know how to do that. Might come in handy sometime down the road.